Hello everyone. So in this session, we are going to see about complex number representations in different forms. So the first form where a complex number can be represented in any multiple forms. Okay. So first is uh, we call it as an algebraic form. Algebraic form. It is also called Cartesian form. Cartesian form. Okay. So every complex number we know that z is equal to x plus iy. Okay, where x comma y belongs to real numbers. See, x and y belongs to real numbers, but I, whenever it is associated with I, then that will be imaginary, the imaginary part. Okay, and I equal to square root of minus. See, for example, now we have seen 2 plus 3i. If you see 2 is real number, 3 is also real number, but this complete thing will be an imaginary. Okay, now, so every complex number represents the form of z is equal to x plus y. So where real of z is equal to x and imaginary of z is equal to y. And then argument of z is equal to theta, which is equal to tan inverse of y by x. We know tan theta equal to y by x. So theta will be tan inverse of y by x. So the inverse functions, those who don't know, I will be explaining in the trigonometry session. So it will be tan inverse of y by, which is the argument. When I say argument, by default it will be amplitude, that is principal value. Otherwise, general value. So if they don't give anything, means it is a principal value. Otherwise, general value is which is 2n pi plus, like that. Okay. So this is how actually a complex number is represented in the form. Now, in the algebraic form. Now we will see another form, which is trigonometrical form. Trigonometrical. Trigonometrical form. This is also called polar form. Polar form. Polar form. Okay. Now draw this graph. I mean the plane. Draw the plane here. Now I have P here. Okay. Now I have P here. This is your Y. So this is your Y. So this is your X. And this is your P X comma Y. And this will be R equal to mod Z. And this will be your theta. Okay. Now, if you see, this is your R, which is your modulus. Now, I can write X. What is your cos theta? X by R. That means your cos theta will be your adjacent side by hypotenuse. So, X equal to R cos theta. What is your sin theta? Y by R. So, your Y is equal to R sin theta. So, that means Z is equal to x plus iy. I can write the same in polar form as r cos theta plus I into r sin theta. So if I take r common, I'll get cos theta plus I sin theta. So this short form I can write as r cis theta. This is the short form. R cis theta. Okay? R cis theta. Let me draw this. This is the polar form. Okay, this is the polar form. See, for example, if there might be a question like uh, there is a complex number which is in normal algebraic form or Cartesian form, like z is equal to minus 2 plus 3a. Okay, z is equal to minus 2 plus 3a. Okay, now what is your this one? So if you take your convert this to polar form, That means minus 2 plus 3i means where it is here, right? In the second quadrant. In the second quadrant, always it will be pi minus, if this is, so if this is alpha, okay, or so pi minus theta, this will be pi minus theta. As we seen, right? The principal argument is pi minus theta. Okay. So here it is your 2. This part is 2. And this part is 3. So what is your principal argument? Pi minus tan inverse of, see, if this is alpha, tan alpha is how much? Tan alpha is opposite side by adjacent. 3 by 2. Tan alpha is 3 by 2. Your alpha is tan inverse of 3 by 2. But mine is pi minus alpha, right? See, pi minus alpha, right? This is the angle alpha, so it will be pi minus alpha. In the second case, we have seen the earlier. It will be pi minus alpha. It is now pi minus tan inverse of 3 by 2. Right? Pi minus tan inverse of 3 by 2. Then what is, that means this is my theta. Then what is R? R will be your argument. Argument is what? Which is nothing but the modulus of z. R is your modulus of z. So which is your square root of minus 2 whole square plus 3 whole square, which will be your root 13. Root 13. So then what is your complex number? So z is equal to r cos theta, that is root 13 cos theta. What is your cos theta? Cos of pi minus tan inverse of 3 by 2 plus common, take common. Just okay, so 3 by 2, okay, take root 13 common plus you take this also bracket I sine of pi minus in place of theta substitute this pi minus tan inverse of 3 by 2. That's all. See, r into cos theta plus I sin theta. This is the formula, right? This is the formula to express in the polar form. But theta is how much? Pi minus. Why pi minus? Because it lies in the second quadrant. So pi minus tan inverse of 3 by 2. So r is equal to mod z, which is your a square plus b square. Your a plus ib. A square plus b square root 13. So r into cos theta. Theta is pi minus tan inverse of 3 by 2 plus I sine of pi minus tan inverse of 3 by 2. This is how you will convert that into polar form. Okay. So in shortcut, how will write? In shortcut, how will write? Root 13 cis pi by 2. Sorry, pi minus tan inverse of 3 by 2. So this is your, okay. So there is one more form called exponential form. So there is one more form called exponential form. So what is your exponential form? Z is equal to x plus I1. This is your algebraic form, and in polar form, which is your r cos theta plus I sin theta. So this is your polar form. This is your algebraic form or Cartesian form. This is your polar form. Okay. And exponential form, I can write it as r e power I theta. E power I theta. That means this cos theta plus I sin theta, I am writing it as e power I theta. Okay. So cos theta plus I sin theta, in the exponential form I will write as e power I theta. Okay. So what will be cos theta minus I sin theta? I'm just asking. So wherever I is there, replace with minus I, which will be e power minus I theta. That means I is replaced. I replaced by minus I. Okay. Fine. So this is your exponential form. Next, there is also one more form called vector form. Vector representation of a complex. See, vectors. I'll be explaining. There is a separate module, vectors and three dimensions and all that. See, for now, vectors means you can think like vector is having some direction. Now you see. Now I have okay. Now you see here. Every complex number can be considered as a position vector of that point. Okay. So it means suppose you have complex number like this. So P. So this is one complex number. So I can just say position vector. So this is your O. O. So OP represents position vector. That means it is having some direction like this. OP. Okay. So a vector is represented by position vector. This is your complex number, say Z. So vector representation means so a direction. They will be having a direction. So this is a position vector. That means there will be so position vector of that point. That means it is a direction. There is a direction from the O. So I'll just write like this OP. So if this is x plus iy, so OP bar is equal to z, which is equal to x plus iy. So modulus of OP bar, vector is represented as a direction. This is equal to square root of x square plus y square, which is equal to mod z. Okay. So these are the different forms of complex numbers. In the next session, we'll be studying the other topics like De Moivre's theorem, and we'll solve some problems and all that. So keep subscribing, keep watching these videos, and then please subscribe to this channel, and please use exercise.in website also. And thank you for